Okay. Lecture 13. Number 13. What about it? Is prime number. Oh, some announcement. Okay. So there are some change regarding the homework and the midterm. So the change are the fact that homework 5 is due Sunday. Okay, not Thursday because the other section needs some time to catch up with the material. And that means also that the midterm gonna be due next Sunday as well. Not, I'll change the thing on Canvas later. Okay, I'll change the thing on Canvas later. Sounds good? Any complaints? And let me remind you, the midterm gonna cover homework 1 to 5. Okay, there are some midterms lying around on the canvas. Divide and conquer current. And let's wait 2 seconds. Where are people? Why are there only 17 of you? Why are there only 17 of you? What happened? What did Ajahn Kanat do to you? Wait, Ajahn. Midterm will be posted, I think, early next week, Anapat. Okay, what? When is midterm for numerical? We discussed it in class, except I don't remember. When was it? We discussed it in class, but I don't remember when was it. Next week, which is next week, yes. Yes. Good luck, Saran. It's not that hard though. Like each one of them requires 2 hours until you give up. Okay, let's go back to this. Okay, so let's look at this. Let's look at this. So today we're gonna learn how to do something called divide and conquer recurrent, which is actually one of the most important algorithms in computer science, right? So essentially it's the same idea, throwing job to your friend, except your friend now like half as fast. Okay, so let's do this. Let's consider the following problem. So if you look at the stock, okay, here's the stock price. This is the time, and this is, I don't know, what's famous today, Tesla, or let's say this is Tesla or Bitcoin. That's probably more suited to you. Okay, and then if you look at the graph, right? Okay, so here's the price. So let's say you are an oracle. You know the price history, right? You know the price in the future for the whole time, like this graph. Then But you don't want to trade very often, right? Because if you trade often, then people get suspected that you know the future, right? So you want to trade exactly once. That means you want to let me modify the graph a little bit. That graph was good, except it's not quite there yet. Okay, so let me make this thing go to the roof as well. So, but you want to trade exactly once, right? You want to buy, then sell. Okay, so after this graph, right? Actually, I don't want this guy. You want to buy, then sell. Okay, so look at this graph. You know, you want to buy it here, right? And sell it there. Okay, so the problem that we're trying to solve is called the maximum profit buy and sell debt. Okay, so for example, that's something you don't want to do, right? Okay, that's something you don't want to do. So for example, you don't want to buy. So this is not exact. I want to show you that this is not exactly finding the minimum and maximum. Not exactly. Find min, then max. Right? This is not exactly that. Okay. So for example, maybe I'm a little bit off here. Wait 2 seconds. Let me erase it. Okay. Let's see. If the graph looks like this, then even though this guy is the minimum, right? This guy is a minimum, but it's not exactly what you want to buy, because if you buy it, then you can only make this much profit, right? But if you buy here and sell there, then you can make that much profit. Okay, is everyone good? Is everyone good with the question? The question is, you know the future, but you don't want to buy and sell too often. You only want to buy once and sell once, and you want the maximum profit. Okay, and it's not exactly like figuring out the minimum. Okay, is everyone good? What would you do? What would you do? What would you do? How would you solve this? How would you solve this? Right? Think about this. You have like an array of price on every day. Try out different period of time. Very good. So how about here's one way to do it. Here's one way to do it. You could do the following. This is actually a very common interview question though. Very common interview question. Double O, very good. Right. That's actually what I would do. You know what? That's actually what I would do. If I have to if I have to do it, then this is what I would do. If it's waitable, if it returns to me within 5 seconds, then oh, I'm good. Then I don't need to figure out a smart way to do it because it returns to me within 5 seconds. So you could do the following, right? Let's say that the buy that you can try. If I buy one and sell at 5, what's the profit? Sell at 6, what's the profit? Sell at 7, what's the profit? And then you can try buy at 2. Oops, actually, I should do the following. 2, 3, 4. This is what Nawat was suggesting. Double for loop, right? Sell 3, sell at 4, sell at 5, and then I compare all this. I collect all this and then I compare it, right? And then I'm gonna figure out when to buy and when to sell. Okay. So for those of you who take class with Ajahn Kanat, you probably know about big O already, the complexity of this algorithm. How much is it? How much is it? How much is it? Very good. O(n) square, which as a computer scientist, you should scream. You should scream. N square is actually not a screamable complexity. Is something you can negotiate with. Okay. But typically you want something linear. or sublinear if possible. Okay, n square is a bad idea. Can anyone tell me a better way? Can anyone tell me a better way? Something better than O(n) square. Something better than O(n) square. The topic of today, by the way, is called divide and conquer. That means you will need to divide and then you need to conquer, means like use your friend. Okay, so let's think about this. Let's think about this in terms of divide and conquer. This is what you should think about when you do like any algorithm that you expect it to go sublinear or something better. Right, divide the graph in half. Okay, actually I can use technology to divide the graph in half. 2 seconds. Copy and paste. Wait, why is it smaller? Okay. Okay, so let's say you have a graph, right? So you have the time. So Justin suggests, okay, Ajahn, maybe we should do the following. We should divide the time in half. This is the time. This is the begin and end. Aha, I divide the time in half. Then what? I have the left and I have the right. Then what? Remember, we want to figure out the maximum buy and sell day. What could happen though? Can you tell me? What are the cases that could happen about buy and sell day if you divide the thing in half? Buy the half with higher profit. Now what? So what Nawaz said is very interesting because he said, okay, how about because this thing looks like the same problem that we had before, except now the size of the problem is divided by a half. So how about I use my friend to figure out what's the best buy and sell date? Sell dates or L, right? And then I use another friend, right? And then I use another friend to do it. Okay, how about best buy and sell dates? Ignore the fact that maybe you have odd number and even number. Let's assume that you can divide by 2 other ways. It actually doesn't matter for us. Okay. Or R. Okay, so far so good. Do we miss something though? So we could do the following, right? You could ask your friend who knows how to get the answer for the left, and you could ask your friend who know how to get the answer for the right, right? And tell me, and then you could do the following. You could compare which one more profit. Is everyone clear with this strategy though? Is everyone clear with this strategy? Everyone clear this strategy? So let's say you have 100 days. You give the first 100 days to the friend called L, right? And you give the last 50 days to the friend called R and have them figure out, okay, if I were to buy and sell within first half, what's my profit? And this thing is within second half, what is my profit? Right? And then we can compare. But do I miss something though? Can anyone tell me, did I miss something? Do the same with cheapest buy? No. The L already tells you that, okay, Ajahn, you should buy on the day number 10 and sell on the day number 22. And this guy can tell you, okay, Ajahn, you should buy on the day 58 and sell on the day 72. That gives you 10 baht profit and that gives you 20 baht profit. Right. So good, right? Then you can compare. But right, like a lot of you said in the chat that, wait, Ajahn, you missed something, right? What about if I buy here and sell there? There is another case, right, that I need to compare it with, right? That means we do not compare only L versus R, but there's a thing in between as well. Anyone has a good idea though? How do I figure out easily? How do I figure out easily though? How do I figure out easily about when to buy? If I were to buy in L and sell in R, when would I buy? If I were to buy in L, when would I buy? Lowest in L, right? So that means I will need also from L, I need also the minimum, right? I need also the minimum. And when I sell, I would sell at the maximum in R, right? So I would need the maximum in R, right? So that's good. So here's the strategy. You need to compare three things. Okay. So you need to compare three things. The first one is buy in L, sell in L, which we can use our friend. The second one is buy in R and sell in R. Again, use your friend. But there's a third one, buy at minimum L and sell at maximum R. Right? For this one, you kind of need to find the minimum and maximum on both sides. Are we good? So we need to compare these three things to figure out which one is the best. Okay? Is everyone good so far? Is everyone good so far? The problem looks like recurrent. We're gonna write exactly what this recurrent is. Oops. Any questions so far though on the algorithm on what we are trying to do? Okay. So let's do exactly that. So let's repeat this. Okay. So let's try this as a recursion. Let's try this as a recursion. So we say that the amount of time, or you can think about it as the amount of comparison that you need. So the T of n, right? Number of comparison. To find buy and sell date. It's called optimal. This algorithm is actually used in real life though. So for example, this graph, you can do some voodoo like dark magic machine learning ish to predict it. Whether it's correct or not, that's another question. And then you can run through the optimal buy and sell date. Okay, so how much? So this is the total cost, right? The total number of comparison. Okay, the total comparison to to figure out buy and sell date for n days, right? Is T of n. What is it equal to? So it's gonna be equal to the cost for all these three added together, right? And with some little bit of cost later, right? With a little bit of cost to compare the three. So can you tell me for number one, how much is it? How much does it cost to call number one? You give your friend half the problem. So how much would he charge you? You give your friend half the problem. Not n over 2, right? But t of n over 2, right? Because what do you think your friend do? Your friend gonna do exactly what you did. Your friend gonna give your friend a friend half of the problem, which is a quarter of a problem, right? Seven good, right? This is for number one. This is for number one. What about number two? How much is it? What about number 2? How much is it? The same, right? Going to be another t of n over 2. This is for number 2. Okay. For number 3, how much is it? Find the minimum on the left and find the minimum on the right. Find the maximum on the right. How much is it? Find the minimum on the left. How much is it? No, not one. To find the minimum, you actually need to do something. N over 2, right? Actually, minus 1. There's a minus 1, but you can ignore that as well. You actually need to do only n minus 1 over 2. Because you pick the first one. The first guy doesn't get compared to anything else. Okay. So this is to get the min in L plus the same idea, max in R. Okay, so that's good. And then there is a cost for you to compare which one gives you the best value. How many comparison is needed to compare 3 things and finding the maximum? How many comparison is needed? 3, not 3, actually 2. 2. Right? You compare the first one with the second one, whichever one wins, you take that one, and then you compare whatever one win with the third one. So there are only 2. That's why there's a minus 1 over here for the same reason. Okay, that's why there's a minus 1 there for the same reason. And I really like that minus 1 because it's going to cancel out. Is everyone good with this concept though? Is everyone good with this concept that you throw half the problem to your friend and hope for the best? Can I explain? Yes. Okay. So to do the job, right, to find the job for n days, what you need to do, you need to throw half the problem to your friend, the left, and another half of the problem to your friend on the right, right? We agree on that. So that's going to be Tn over 2 plus Tn over 2. Okay. And then we're going to need to find the minimum in L and maximum in R because you can buy on L and sell on R. And to find the maximum is n over 2 minus 1. Okay. And to find the maximum is also n over 2 minus 1. And after we get all these 3 answers, right? All these 3, we need to compare which one is the maximum among the 3. And that takes 2 more comparison. How many friends do you have? I don't know. I just need a guy who can do half my problem, but my friend will need a friend who can do half of his problem. Why do we need minus 1 to find the max? So for example, let's find the max of 3 numbers. Okay. Right. Then you take 10, take, not compare, and compare with 12. Whichever one wins, you compare it with 5. And then you know which one is the maximum. So for 3 numbers, you only need 2. So for 3 numbers, you only need 2. Okay, so far so good. Any more question? Any more question? I need that minus 1. And the reason I like minus 1 because it's going to cancel with that 2. That's why I like it. That's why I keep it. Otherwise, I don't really care. Because, you know, at the end, when you do algorithm, right, you don't really care about the lower term. That minus 1 is actually nothing compared to the rest. Okay, so let's combine this. Let's combine this. So you're going to get T of n is 2 T of n over 2 plus n. Someone get? Is everyone get? This is a little bit different from last time, right? So from last time, the number here goes down linearly. But this time you divide by 2 every single time. So you go down much faster, right? The problem size goes down much faster. So let's say if you start with 32, you go down to 16, you go down to 8, you go down to 4, you go down to 2. Okay. And then you're gonna find out that, okay, if it goes down like linear, like last time, it's much slower, like 32, 31, 30, 29. So you can imagine it's gonna take more time to do the linear one. Okay, so this is called divide and conquer recurrent and conquer, not command and conquer, which is a really good game. You guys probably not born fast enough. You guys probably not old enough. It's a really good game though. It's called command and conquer. Divide and conquer recurrent. You have teeth. AOE is good game. And there was way back then in the same like golden age of RTS, there's a game called Heroes of Might and Magic 3, which you can probably find on GOG. Good old game. It's a really good game. The game mechanics is like perfect. Okay, let's go back to here. So let's think about this. If we have this recurrent, can we find out all the t's? Let's say if I want to find t of 32, can we find that number? What is missing? What is missing to let me find t of 32? What's missing? What is missing? Anyone? What is missing though? What is missing? Last time when we have the linear recurrence, we need another thing, right? The value for each day? Not really. We need the base case, right? Eventually someone gonna need to do the job, right? So eventually someone gonna need to do the job. Okay, so the guy who you know how much job he does, which guy you know? If the problem is small enough, you can tell the answer right away, right? T of 2. If you are given 2 dates, what can you do? What can you do? Compare. Why do you need to compare if you're given 2 dates? You don't even need to compare. I think in the lecture note, I might compare it, but that doesn't matter. So what good, right? No more comparison is needed if T2 for T2. So this alone, right, can get you to any T's. Well, at least for some number that we know how to calculate. Okay. Y is 0. Let's say I have you 2 days. You give you 2 days, like Monday and Wednesday, the price for Monday and Wednesday. And I ask you, buy once and sell once. Do you really need to compare it? You don't, right, Alexei? Right? If I give you 2 days, buy once and sell once. No need to compare. That's easy. Okay. So let's do this. Let's try to solve this. Let's ignore the fact that the price fluctuates. Let's ignore that practical fact. Okay. So let's do this. We want to solve for it, right? There are many ways to solve for it. The first way we do it is we just plug in the numbers. Okay, let's try. We have T2 is 0. Okay, let's do T of 4 because I know how to calculate that number. T of 3, let's ignore it. Don't worry. T of 4. Okay, now here's the thing. It's gonna be 2 times T of 2, right? That 4 is n. T of 2 plus how much? Can you tell me? Plus how much? Plus 4 plus 2. That's a real question. Plus 4. That's good. So that would be 4. That's good, right? How about t of 8? Okay, gonna be 2 times t of 4 plus how much? 4 or 8? Even though I asked you, trust me, someone's gonna do it wrong. Someone's gonna do it wrong. Okay, so that is going to be what? 8 plus 8, that's 16. Okay, let's do t of what? 16 is 2 times t of 8 plus 16, you know by now, right? So that is going to be what? 32, that's 48, right? That's 48. And t of 32, that's 2 times t of 16. Make sure I didn't screw up the algebra though, otherwise we're gonna have a bad day. Plus 32, so that's gonna be 96 plus 32, 128. So that's good. Now we need Karit's power. Is he here? Is Karit here though? Karit, are you here? I need your power. Ah, you're here. One chip in. Something when you plug in 4, you get 4. When you plug in 8, you get 16. Right? You plug in 16, you're gonna get 48. But when you plug in 32, you get 128. Anyone? Can you stare at the number and tell me what it is? Anyone? No? Okay. So let's do this. Okay. So let's assume Karit gave up. At least I gave up. Okay. Gave up on staring. Right. So you would think that, okay, Ajahn maybe it's multiplied by 2, multiplied by 3, multiplied by 4. Ah, that's actually very close. We need something. I'm hungry. Okay. Let's try to do what we did last time. For people like me who are not very smart at staring at the number. Give such job to friend to think. In the exam, please do it yourself. Please do it yourself. It's actually very easy. And to the end, now think about this. 32 to the 32 is something much larger than that guy, but you're close. Okay. So here's what we're gonna do. Give up on staring. ING. Gave up on staring. Okay, so now let's do something more concrete. We're gonna do plug and chuck. But you know, when we do plug and chuck, right, it's hard because it's now divided by 2 every time. So let's try to figure out what is t. Let me let's headache. T of 2 to the k. And the reason that I want to do this, right? And the reason that I want to do this is because I'm gonna need to divide by 2 by a lot. Right? I'm gonna need to divide by 2 by a lot. So let's make sure that I do not get fractions, because when I get a fraction, I don't know what to do. Okay. That is actually a literature on how to take care of round up and round down. But all in all, typically you can just ignore the fact that you round up or round down. 99% of the time, you can ignore the fact that you round up or round down. Okay, so let's start with t of 2 to the 5. Okay, and the reason I write 2 to the 5 because I know I'm going to need to divide by 2 like so many times. Okay, that is, this is again plug and chuck. Yeah, like what we did last time. Remember that n is not 5, n is 32. So let me write over here. N is 2 to the 5, but k is 5, right? So it's 2 to the k. Okay, so 5 is k, but n is 2 to the 5. Okay, so let's do this. It's going to be 2 times t 2 to the 4 plus 2 to the 5, right? This is what it is. Let me move this guy as well away. And you go away. And let me do this. T of, which is equal to 2 times, right? T of 2 to the 4th is 2 times t of 2 to the 3rd plus 2 to the 4th, right? Plus 2 to the 5. Again, do not clean up. Do not clean up because you know, you want to know what each term adds to the expression. Okay, now let's clean up a bit. So you get 2 to the 2nd times t of 2 to the 3rd plus 2 to the 5th plus 2 to the 5th. Someone with me so far though? We're gonna get to it to the end. Okay, so 2 to the 2nd times 2 to the 3rd. Let's do that. 2 to the 2nd. That's gonna be t of 2 to the 2nd plus 2 to the 2nd plus 2 to the 3rd, sorry, plus 2 to the 5th plus 2 to the 5th. So that's okay, right? So that's gonna, oops, I forgot 2 over here. Gonna be 2 to the 3rd, t of 2 to the 2nd plus 2 to the 5th plus 2 to the 5th plus 2 to the 5th. Are you guys with me so far though? It's a lot of algebra, but you can kind of see the pattern. But let's go through it to the end, because you know eventually as you do it, you're gonna get more and more 2 to the 5th. But let's count how many terms there are. Okay, so that's gonna be 2 to the 3rd times t2 times 2 times t2 plus 2 to the 2nd, right? Plus 2 to the 5 plus 2 to the 5 plus 2 to the 5, which this guy is 0 by the base case, right? It's going to become 2 to the 5th plus 2 to the 5th plus 2 to the 5th plus 2 to the 5th. Are you guys with me so far though? In the lecture note, there's a +1 and -1. That depends on how you count the number of operations. I made it clean this time. But remember, it looks clean. But I want to figure out the fact that there are 4 of these. Let me ask you, what is t of 2 to the k? What would be your guess given this? The fact there are 4 terms, where do you think the 4 terms come from? In terms of n or k? Right, in terms of k, where does 4 come from? Very good. It's k minus 1, right? Right, and then you need to multiply by n, right? 2 to the k. So you can imagine that t of 2 to the k, right, is going to be k minus 1 times 2 to the k minus 1. Wait, 2 to the k, sorry. But if you think about it, I want it in terms of n, not k. Can you change all these to n? And change all these to n. So that 2 to the k, that's clear, right? Because n is 2 to the k. So we get that thing becomes an n. What do I do with k minus 1? How do I turn it to n? What is k in terms of n, by the way? What did you learn in high school? Very good. It's log base 2, right? Because n is 2 to the k, so that means k is log base 2 of n. You learn nothing in high school. No, sorry for you. I actually learned nothing in high school too. Okay. Or, in other words, it is n log base 2 of n minus n. Right? Karit would have guessed exactly this expression. It's t of n. Karit would have guessed exactly this expression, except he was quiet today. First of all, okay, but when you do this, be careful, be careful. I really want you to check your answer because you know amount of algebra you do over here, right? Because you do a lot of algebra over here. The chance that you're doing something wrong above is so high. So let's plug in the numbers. Okay, let's plug in the numbers. Okay, so T of 4. Let's do this. T of 4 is 4 log base 2 of 4, right? Minus 4. So that would be 8 minus 4. That's 4. Because let me get a nice highlight color. Because this thing is n, and there are k minus 1 of them. Okay, let me go back to here and let me change the color a bit. Okay, let's do T of 8. Now the magic part comes in, right? So it's going to become 8 times 3, right? Log base 2 of 8 is 3 minus 8, which is exactly 16. And T of 16 is going to be 16 multiplied by 4 minus 16. That's going to be 48. And you can trust me on T of 32. That's going to be 32 multiplied by 5 minus 32, which is 32 times 4, which is 128. Right? That's good. So this is something you probably never guessed before. But think about this. Any questions so far, or any questions so far about the process we went through so far? It's actually very mechanical. So if you know what you're doing, just plug and chuck, right? And see the pattern, where's n, where's k, and then combine. You're going to do some of these in homework as well. There are like 3 or 4 of them. Okay. This kind of expression you're going to see a lot when you try to solve something along the line of algorithm that has to do tree or graph, because you essentially split your problem by half. Okay, so another question is this better than before? Is this better than before? Last time, remember the thing that Nawaz suggests was n square, right? Versus n square. Is it better than before? Yes, right? Think about this. If n is like 2 to 100, right? If n is 2 to the 100, let's plug in some number. You're gonna see why quadratic is bad. Let's 2 to 100 is not actually too much. Let's say 32-bit number, 2 to the 32, about 4 billions, right? N squared, that gives you 2 to the 64. Wait until you die. It's not gonna happen. 64-bit. It's not gonna happen. 2 to the 64 is probably like how hard it is to mine a Bitcoin. What? 5 years ago, 10 years ago, 2 to the 64. But n log n, that's 32 times 2 to the 32. That's much better than that guy. This is about 2 to the 37. So it's like order of magnitude better. N log n is good. Sound good? Okay, if you can get it down to a log n, that's probably where I stop. So once again, any questions so far though? Any questions so far? Any questions so far regarding this? Okay, you're gonna do some of it in homework. Log has many use, that one use. That's one use. If you this relies on a big if you know the future, Justin. Yes, this is what you do. If you know the future, yes. Okay, but for those of you who learn algo, I think none of you learn algo. This actually, you can actually get down to T of n is big O of n with dynamic programming. You can learn it with Ajahn Sanser. You can do this a lot faster. You can do this a lot faster. You're gonna learn it. Okay, wait until you learn something called dynamic programming, or you can Google or YouTube lots. Dynamic programming. This programming is not the way that you program. It means how to schedule stuff, how to assign stuff to the resource. That's programming way back then before you actually learn how to code. Okay, you can actually get this thing down to O of n with dynamic programming, which you gotta learn with Ajahn Sanser. Maybe 2 or 3 terms from now. Okay, any questions so far though? Any questions so far? If not, is it in our yes, it's in our class. It's one of the most important techniques. Some people call dynamic programming like brute force. It's a bit brute force. Really, it's a bit of brute force. Get it down to O of n. So I just show you how to turn a physical problem into a recurrent and then solve for it. There's actually another way to solve for it, but you can read the lecture notes. It's actually counting the working tree. You can read the lecture notes on it. Sometimes it's better that way. Sometimes it's better. I like this way. This way gives you the answer. The other way gives you a nice picture. The other way gives you a nice picture. Okay, if no more question, we are going to take 10 minutes break and let me find the chat window. Where is it? Okay, so let's go come back at what time? 15:00. Okay, let's come back at 15:00. We're gonna learn something new. what question 5? W plus L equals to 2 or W minus L or something. What was the question? Oh, that Kanat's homework, right? Hanoi. The hint is use your friend. The hint is use your friend. Yes, midterm gonna be due next Sunday. Right. The trick is don't try to solve it yourself. Use your friend, which is you. Okay. Okay. Use a friend named PT. No, I don't have time to do anything. I'm extremely busy this week. I don't know why people put a lot of things on my schedule. They kind of need me in the meeting for moral support. Are you teaching physics to Ajahn? No. It's Ajahn Thanet and Ajahn Vitul. Why? They are really good teacher. They are really good teacher. It's Ajahn Thanet and Ajahn Vitul. Physics 1 should be easy for you, know what? Physics 1 is like high school physics. that most of international school students didn't take. Okay, now let's do this. Okay, what we're gonna do now is a new topic, which is not on the midterm, counting. Okay, so this is, by the way, okay, if you didn't do physics in high school, then good for you. It's time for you to learn. This thing is homework 6, not on midterm. And it's actually my favorite subject. Counting is actually my favorite subject because there's actually nothing to learn except you need to learn it through examples. Okay, so let's do this. Okay, so there are two rules of counting. So for example, if I have that, and that, okay, 1, 2, 3, and 4. And then I ask you with a really simple question. I ask you to count how many of these are there. Then the simplest thing for you to do is, okay, Ajahn, this is 1. I'm gonna look at this and I'm gonna mark it 1, gonna look at this, mark it 2, gonna look at this, mark it 3, gonna look at this, mark it 4. But while you're doing that, you are asserting 2 rules when counting. So the first one, well, is actually 1 rule. So counting is learning how to count everything once. Count everything let me important everything and once each. Okay, so for example, you can see that there are 4 circles on the top section over here on the top section. So if you are counting and then, okay, maybe Ajahn, I'm going to count this as 1, 2, and 3. Then you did not count everything, right? You did not count everything. Or if you screw up, like if you count that 1, 2, 2, 1, 2, and 3, 4, and 5, then you count everything, but you didn't count it exactly once each. Okay? So this is what we learned how to count. So you may think, Ajahn, counting is easy. I learned it in kindergarten. Just wait. Just wait. When the number is big, then you want to do it more systematically than before. Okay? Okay, let's start with something easy. Let's say you have, I don't know, the choice for breakfast. Okay, for breakfast, you can have, I don't know, porridge. What else do you guys have for breakfast? You can have cereal. What else do you have? Scrambled eggs. Okay, good. And what's gonna say Subway? Subway was in Thailand for a long time, but they just only got popular. Buffet for breakfast. Actually, that's not a bad idea. Yes, Subway opened very early. Sometimes for breakfast. Okay. Patty, wait 2 seconds. I'm gonna make, okay, so sometimes it's probably for lunch, right? Okay, sometimes my favorite food until COVID came, and then I realized something very important, that sometimes doesn't get through heat, and if the person who makes sometimes has COVID, then we have COVID. So I paused on sometimes for quite a while. It's actually one of my favorite food. Okay, curry rice, good. The thing that Keith said, I have no idea how to read. I have no idea how to read kanji, but what Saran said, I know. And then pad kapao, okay. Basil, chicken basil. Actually, if you can tell me the food and then which shop I should order on Grab. And then there's burger. There's a really good burger shop on Grab called Cow Nap. You can search this one. Maybe if it's close to you. Eat it before they get famous. Search this on Grab. Really good burger. Really good burger. And that includes the burger I ate in America. This one is really good. Search for Cownep. Okay, let me give a free advertisement for this guy. Eat it before it gets famous. You know, Saraya, there is a ramen shop called Shindo Ramen at Saraya. I don't know if you guys ate it already. Way back then, when he opened the shop, the shop is not that famous. I went there and there was no queue, and then I know that the ramen is good. So I went there like every week with students until someone posts it online and then it gets so famous and then the queue is like 2 hours long. Then I gave up. So this guy eat it before it gets famous. Okay, so you have this, and for dinner, it's หลังมอ it's หลังมอ search for Shindo Ramen. Shindo Ramen. The chef actually knows what he is doing. Sometimes he gave me a new ramen to taste as well. But then he gets famous and then, okay, we don't meet each other anymore because the queue is too long. Okay, so for dinner, what do you eat? What do you eat? Maybe, what else? Subway. 7-Eleven, oh, so sad. Steak. When you're young, you can eat everything, right? Pizza. And instant noodle, so sad. Fine dining, okay, keep you rich. Okay. Okay, now let me ask you a very simple question. How many ways are there to have your meal in a day? For a day meal? 300, 60, and you think you overcomplicated things, right? Okay, so now here's the one. Let's think about this. Okay, so the question is simple, right? So you multiply 3 because you have 3 choices for breakfast, right? And each one of them go out to 4, and each one of them go out to another 5, right? So if you count all the combinations, I think it's quite clear to you that this thing is going to be 3 times 4 times 5. So that would be the first thing that you learn, right? You multiply if it duplicates itself, right? So for example, porridge, and so this thing is exactly the same thing as you go here. Okay, so I think everyone can see that 3 times 4 times 5. It's clear. Okay, now how about this? How about this? Let me ask you something. Okay, so the first one is done. 3 times 4 times 5, that's easy. What if, because I know you guys do not eat 3 meals a day, right? You guys do not eat 3 meals a day. What if I allow you to skip at most 1 meal a day? Okay, so what that means is the following. What that means is the following: porridge, and then som tam, and then skip is the same thing. It's not the same thing as porridge. It's not the same thing as, and then what? Som tam and then steak. These two are different. What if I allow you to skip at most 1 meal a day? I'll give you 5 minutes to think about it carefully. Think about it carefully. That means you can skip breakfast if you like, but you cannot skip breakfast and lunch, right? You can skip 1 meal. If you skip 2 meals, you kind of starving, right? You are starving. What if skip at most 1 meal? I'm gonna give you 5 minutes and then type your answer in the chat, and then we're gonna look at each answer. Up to you, up to you. Up to you. There are many ways. There are like 10 ways to do this, and each answer gonna give me a hint on how you do it. And some answer gonna be wrong, but the most important thing that you're gonna learn in this section is most of your answer gonna be wrong. That's the first thing. Most of your answer gonna be wrong, but the most important thing is how to learn how to fix your answer. If you know what's wrong with it, right? If you know what's wrong with it, then you need to know how to fix it. Okay, skip at most 1 meal. I'm gonna give you, I don't know, 3 minutes, 3 more minutes. Today, now it's 11, so I'm gonna ask you at 14 and then type on the chat. Breakfast. For lunch, 5 dinner, and then skip as mode on 1 meal. And we will also see how democracy works in class. Is there a trick to add most 1 meal? No, it's not a trick. I just want to be clear. Add most 1 meal, so that means you can skip 1 meal or eat every meal. It's okay. It's okay. Even if you give me the wrong answer, then we're gonna learn how to fix it. Learning how to fix it is very important. Okay. Okay. So let me write down the answer. That seems to be like 2 answers. One is the obvious one. 3, 4, 5 plus 1 times 4 times 5. Okay, I want you to see the thought process of others as well, because there are like many ways to count. 3 times 1 times 5 plus 3 times 4 times 1. This is most, also Patty and Saran. Okay. No, not Patty. Who's that? Oh, Patty and Saran. And Luck said 4 times 5 plus 3 times 4 plus 5 times 3. And then that is, you believe in Saran. And then that's Keith. 4 times 5 times 6. Okay, so let's talk about them one at a time. I want to see. There are many ways to do this. Don't worry. But if you count the same thing, right? They should come out as the same number, but they aren't. Okay, so when you do this homework, homework 6, work alone first and then check your answer with your friend, but do not fight them to death. 2 expressions that do not look the same may be exactly the same number. Okay, so let's do this. So the first one, I think, is quite clear. These two are actually related, close by. These two are actually related. Okay, so the first answer, it's quite clear that 3, 4, 5, we did it before. This thing is never skipped, right? Okay. But this one, I think it's clear that you skip breakfast. So 4 and 5 are the number of lunch and dinner. And this thing is gonna be skip lunch. And this thing is going to be skip dinner. And then when you add up, okay, and then when you add up, you got it. But the second one, you just forgot that term. So you need to figure out what went wrong and then how to fix it. Because you know that this thing is clearly skip breakfast, right? This thing is skip lunch. This thing is skip dinner. But it's clear that you did not count eat everything, which is 3, 4, 5 over here. Okay, so it's very important that when you write down the answer in your homework as well, please note like skip breakfast. Please note that this thing is skip lunch and so on, so that the grader doesn't scream because they only see the number. Otherwise, they have no choice but to give you 0 because they don't know what you're doing. Okay, so now Keith's answer is actually very interesting. It's not right, but it's very interesting. We're gonna fix it together. Okay, so Keith's answer, he does the following. How about he think the following? This is actually a very good idea. Okay. He said the following, that, okay, 3 breakfast. How about if you skip, I'm gonna give you an empty plate. Right? If you skip, then I'm gonna give you an empty plate. And this one also an empty plate. Right? So that means if you think about it, right? If you think about it, then you actually have 4 choices for breakfast, 5 choices for lunch, and 6 choices for dinner. Right? The parts are good. So that means that's why Keith said 4, 5, 6, right? You have 4 choices for breakfast, including the empty plate. You have 5 choices for lunch, including the empty plate, and you have 6 choices for dinner, including the empty plate. What's wrong with this? What's wrong with this argument? What's wrong with this argument? Very good, because we can only skip 1 meal a day. So if we do this, this thing includes the following, like it includes like breakfast, skip. It includes lunch, skip. Let me just write down. And it includes skip, and then dinner. And it also includes skip. Okay. So far so good. So that means these are the things that Keith answer counts, but we don't want to count, right? That means if you think about it, oh wait, now I know what's wrong with it. If I can subtract that off, then I'm gonna get the correct answer, right? If I can subtract that off, I'm gonna get the correct answer. With subtraction is actually quite easy, right? So for example, how many ways are here? How many ways are there to have breakfast and then skip? 3. How many ways are there? 4, right? And then how many ways are there? That's gonna be 5. And how many ways are there here? Gonna be 1, right? Skip. So that means Keith's answer is fixable. All you need to do is do this. -1, -3, -4, -5. Aha, right? So this is a skill that I want you to have. Whatever you guess the first time, it's gonna be wrong. So for example, when you guess the first time, you may guess this guy. And if it's wrong, then you know to add the next number. Right. If you don't believe me, just add 3 number, right? So 3, 4, 5 is what? 3, 4, 5 is what? 12, 60? Let me add this guy. Gonna be 60 plus 20 plus 15 plus 12. That's gonna be 80, 95, 107, right? And 4, 5, 6. Okay, this is hard. 120 minus 3, 4, 5. That's going to be minus 9, minus 12, minus 13, which is 107. Okay. They are exactly the same number. And like I said, they do not look remotely the same, but they are the same number. Okay. They do not look remotely the same at all, but they are the same number. Okay. So please write down what you did. You might figure out some smart way to do it. Okay. Any questions so far or any questions so far? Maybe, I don't know. Like I said in numerical method, computers are stupid. You need to phrase the question exactly how it can figure out. Wolfram Alpha is like level 2, a little bit smarter, but you still need to phrase it correctly. But NLP is Python is like one of the dumbest thing. It doesn't know anything, so you need to teach it everything. Okay, now good. How about code 100? So let's do something simple. What Keith said, how many 1 0 there? Okay, 8 ones and 0. Let's say 8-digit binaries. Okay, let's do something along that line, right? Now we learn something, right? We learn that, okay, Ajahn, I can multiply things if they duplicate. I can subtract things if I overcount. I can add things if I forgot to count something. Let's do this. Let's start with something easy. 0, 1, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. Actually, let's make it 10. Let's make it 10. Yeah, let's make it 10. 10 binary digit. Okay, so that is it means it's a string of 0 and 1, and there are 10 of them. How many of them are there? Can you tell me? How many of them are there? No. How many of them are there? This is exactly the same thing as breakfast, lunch, and dinner, right? Except you have 10 meals. How many of them are there? 10-digit binary number. That's probably better vocabulary. 10-digit binary number. How many of them are there? Like this is one of them, right? 2 to the 10, right? That's probably easy because each one is like breakfast, lunch, and dinner. You have two choices, but you have 10 meals, right? So it's 2 multiplied together 10 times, which is 2 to the 10, which is, since you are CS major, you should know this number, 1024. Any questions so far or any questions so far? Okay. How about this? How about this? How about this? I want to know. I want to know how many of them. Actually, that's going to be hard. Let me make the easy one. Okay, sorry about that. Sorry about that. Okay, how many of them? How many of them are of the following form? How many of them has double one next to each other? Okay, let me make sure we understand the problem. Okay. Oops, that's my Netflix. Okay, what I meant is the following. What I meant is the following. So for example, this thing has a double one. This guy. This may be too hard for you right now. Let's pause this one until you know a little bit more. You need to know something a little bit more to make your life a lot easier. Sorry about that. Okay, let's do this. Let's do something close here. Forget about the last question. The last question is hard. Actually, it's hard. Okay, so we're gonna come back to that maybe next time. Next time. Let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. You have 10 digits. Okay. You have 10 digits. And we want to figure out how many digits are there that you can make up with these numbers. Okay, and you need to use 10 of them. So for example, you could do the following. 9, 2, 5, and what did I get? 1, 2, 3, 4, 5, 6, 7, 8. But that's another number. But this is not valid, right? You use number more than once. This is not valid. This is valid. This is valid. Okay. So how many numbers are there? I'll look other way. Right. What we want to do here is to make sure, right, is to make sure that you count them systematically, right? Because if you try to follow and enumerate all of them, now you know that it's quite a lot. What do you think? How many digits are there that use 0 to 9 and you never repeat it? Okay. So Nawat said 10, but with exclamation mark. Actually, it's correct. So let's think about this. Let's think about this. The way we want to reason something like this is the following. Okay. The way that we want to reason something about this is the following. You have 10 slot, right? This is slot number 1, slot number 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? You have 10 slot. Number 5, number 6, number 7, number 8, number 9, and number 10. Right? You have 10 slot. Then what you do, you put in each number, right? You can put 3 here. Okay. So this is again like breakfast, lunch, and dinner. Okay. Whatever you put here, right? You have 10 choices for the number that you want to put in the first slot. Okay. But for the second slot, so let's say you pick 3 already. That means you cannot pick 3 for the slot number 2. So how many choices do you have now for slot number 2? You have 9, right? So 10 breakfast, 9 lunch, and we're gonna have many dinner. And after you pick 2 number, you are going to have 8 choices left, right? For slot number 3, whatever that number is. And then you're gonna have 7, 6, 5, 4, 3, 2, 1. And then you're gonna apply all that together. Okay. And this is the exact definition of the factorial. We're gonna do probability after counting. Okay, we're gonna do probability after counting. We're gonna do it properly because it's probably one of the most important chapter. Besides how to scam people with probabilities. Okay, everyone, so far so good. So this kind of thing about rearranging the number and then there are no duplicates, right? This is called permutation. Okay. So this is a permutation of this. Okay. So the number of permutation of n stuff, number of permutation. If you can get your problem down to permutation, then you can forget about it. That is just a permutation. Okay. Permutation of n items is n factorial. Number of permutation of n item is n factorial. Exactly the same way that we got 10 factorial. Okay. Any questions so far though? Any questions so far before we get to something a bit more creative? Okay, a bit more creative. So let's think about this. That one was easy. That one was easy. How about if you like these three numbers so much? You like these three numbers so much. 5, 6, and 7. Okay. How many numbers are there that 5, 6, and 7 are right next to each other? In that order. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That one you count. 1, 5, 2, 6, 4, 3, 7, 4, 8, 9, 0. That one doesn't count because 5, 6, and 7 are not together. This is counted. 5, 6, 7. 1, 2, 3, 4, 8, 9, 0. That one is counted because they are together. This one is not counted. 6, 7, 5. 1, 2, 3, 4, 8, 9, 0. This one is not counted because not wrong order. Okay, I'll give you 5 minutes. I'll give you 5 minutes. Keep powering in the answer. I'll give you 5 minutes. So let me mark. You know what? It's 7 factorial. And Thanatat is 5 times 7 factorial. I want to know how many numbers, right? How many permutation of 0 to 9, okay? That has the number 5, 6, 7 together in that particular order. So for example, for this guy, because 5, 6, and 7 are next to each other, yes. And this one is a no, because 5, 6, and 7 are not together at all. Wait. 6 and 7, sorry. Oh, okay. Thanapat want to change the answer. That's cool. 6, 7, 5 is no. Okay, so that is around 8 factorial. Keep 7 factorial, which is with you know what? Give you 5 minutes to think about it. Keep typing in the answer. Like I said, this is not really about how to get the right answer, but how to fix your answer. Give us some time. I would like to jump ship and start. Okay. Bye, Keith. That is exactly what I said before. Whatever you do, it's more likely that your first answer is going to be wrong. Then you figure out how to fix it. That's the more important part. To know what's wrong with an answer and know how to fix it. That's very important skill. Okay. Any more answer or any more answer? Anyone more with a more creative answer? Anyone with a more creative answer? Okay. So let's look at this answer. I think everyone has the same idea on how to do this because the thing is it requires some creativity, but it's not that creative. So the idea is if 5, 6, and 7 really want to be together, what we can do, we're gonna pack them together. And we're gonna call that number S for 7. Okay? So instead of having 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, we're gonna have 1, 2, 3, 4, 8, 9, 0, and S, right? And then what we can do, we can count the permutation of this, right? Let's say the permutation of this is going to be 1, 2, 3, S, 4, 8, 9, 0. Okay. And then we can unpack the S, right? Because this thing is one-to-one mapping to the answer that we want, right? 5, 6, 7, 4, 8, 9, 0. That's a one-to-one mapping between our answer and this kind of permutation. Okay, so that means that the number of things are the same. That means if you count one, you get another. This is actually a very important concept as well. If you count one, you get another if there's a one-to-one mapping. So that means because there are only 1, 2, 3, 4, 5, 6, 7, 8 things. So the number of ways to do this is 8 factorial. Are we good? Any questions so far or any questions so far? This kind of thing for counting, it really cannot be taught. You're gonna learn it through examples. So I really want you to think along and get the wrong answer. We're gonna learn how to fix it together. Fixing things is very important. Any questions so far though? If not, let's do another one. Let's do another one. What if I erase this? It doesn't have to be in that order. As long as 5, 6, and 7 are together. So that means this thing is good as well. That means this thing is good as well. Everyone with me, right? 10-digit numbers made from 0 to 9. But 5, 6, and 7 needs to be next to each other in any order. Wait a second. Let me get all your thing. That is Saran 7 factorial plus 3 factorial. You guys are really good. At least you give me an integer. So now what? Give me 8 factorial, 3 factorial, carry. This is 7. 7 factorial plus 3 factorial times 8. And Saran changed his answer to 8. Okay, let me try to read the log. So Keith, 8 times 3. You forget something? Let me wait until 45 and then we're gonna talk about this. Let's keep your answer and then we're gonna talk about it. Like, because even if you're wrong, you need to know what is wrong. What did you double count? What did you overcount? Or you combine things in the wrong way or so on. You think you should multiply, not add? Can you answer correct? Just tell me your final one. So carry move. Okay, good. Your friend moves, Alexei. You're so close. Saran moved too, right? Democracy may work here. Okay, so let's do this together. We move. Right. So here's the thing. I want you to realize maybe if you see the correct answer, you know what's wrong with your answer. Okay. So let me ask Alexei. This is very important. Where does 6 factorial come from? You can sort of get this to work somehow, though. Where does 6 factorial come from? I kind of understand number 6, but not 6 factorial. Uh-huh. Good. Very good, very good. So that number 6, right? So I think Alexi has exactly the same idea as your friend. Okay. So we can go back to the idea that, okay, since they are gonna love each other so much, right? We're gonna call that number S. Okay, we're gonna call that number S. And then we're gonna rearrange it because we know there are 8 factorial of this, right? We agree on that. There are 8 factorial of this. But each one of them are going to correspond to 6 answer, exactly what Alexi said. So for example, we're gonna correspond to 5, 6, 7, and then the rest, and then gonna correspond to 5, 7, 6, and so on, right? And there are 6 of these, or 3 factorial of this, because you are rearranging 3 stuff, right? There are 3 factorial of this. So that's good, Alexi, right? So that means, Alexi, now you want to move, right? Right? So each one of these answer correspond to 6 answer. So that means this one is correct. Okay? So just 8 factorial times 3 factorial. So that's it. Any questions so far though? Any questions so far? We're gonna do more example next time as well. Any questions so far though? If not, we're gonna call it a day. And as a reminder, homework 5 gonna be due on Sunday. And midterm gonna be on next Sunday. Okay. If no other question, we're gonna call it a day and see you on Thursday. Yes, I'm gonna stop recording. Yes, I know you wanna talk to me. I'm like your live counselor. Wait 2 seconds.